Blood spatter analysis, or blood stain pattern analysis, BPA, is a forensic method that interprets the size, shape, distribution, and location of blood stains to reconstruct the events at a crime scene. It is the silent witness that is left behind by violence. BPA has its roots going back to the late 19th century, but it really gained traction in the mid-20th century when scientists applied physics to blood behavior. And in doing the research on this topic, I learned that the correct word is spatter, S-P-A-T-T-E-R, not splatter with the L. A large substance splatters, but small droplets, they spatter. It's a small nuance, but spatter is technically the correct term. And blood, like any fluid, follows physical laws. When shed, how it acts as a fluid is influenced by gravity, air resistance, and surface tension. In flight, droplets form spheres due to the surface tension, and upon impact, they create patterns, telling experts about the speed, direction, and origin of the blood source. To illustrate, consider a simple experiment you could do at home with something like red paint. Drop it from different heights. A low drop will create a larger, rounder stain, where higher drops will create smaller spatter. But that's pretty basic. Let's move to a crime scene where it becomes amplified. Hello everyone, and welcome back to Lawyer Up, the channel where we break down the intricacies of law, crime, forensics, drugs, drug cartels, and everything in between, so that you can understand how the law, or the lack thereof, really works in the real world. I'm your host, Attorney Joshua Roberts, with over 28 years of experience in criminal defense and trial law. Today, we're taking a deep dive into a fascinating topic in forensic science. It's the science behind crime scene blood spatter evidence. We will explore how it works, why it's important in trials, what qualifications an expert needs to testify in court. We will look at a famous case where blood spatter analysis helped to solve a murder, and we'll look at a cautionary tale about faked expertise. So grab a drink, preferably not a red one, and settle in. And if you're new to the channel, hit that subscribe button and turn on notifications so you don't miss any of our deep dives into the world of law. Now, there are three primary types of blood stain evidence that you see at a crime scene: passive, projected or spatter, and transfer. Passive stains result from gravity without any external force. Think drips from a wound, forming pools if you're stationary, or trails if the person moves. These can indicate time, location, movement, etc. Now, transfer stains result from a bloody object coming in contact with a non-bloody object. Think of a killer putting a bloody hand on a doorknob as they leave the scene. These patterns can also indicate location and movement. Now, spatter stains are from force applied to a blood source, and these are further subdivided by velocity. A low velocity impact spatter, LVIS, forms from forces up to 5 feet per second, like, say, gravity or a punch. These stains are larger, often over 4 millimeters, and they often have scalloped edges. Then we have medium velocity impact spatter, MVIS. These form from forces of between 5 and 25 feet per second. These are the kind of droplets you see at the scene of a severe beating or a stabbing. These stains are usually between 1 and 4 millimeters and are less round and more directional. Finally, we have high velocity spatter, HVIS. These occur from forces of over 100 feet per second, from usually gunshots or machinery. In these instances, the spatter is a fine mist, almost like an aerosol, and usually the droplets are under 1 millimeter in size and sometimes not even detectable by the human eye. So the size of the blood spatter tells you a lot about the force that was used to generate it. But so does the shape, because the shape reveals the angle from which the blood arrived. A circular spatter suggests a 90-degree fall. An elliptical spatter suggests a shallower angle. Analysts can actually measure the width and the length of a droplet to calculate the angle of impact of the blood. And this does get a little nerdy, but to determine the exact angle of impact, you use a trigonometry formula. It is the angle of the blood spatter came from the arc sine of the width of the blood stain divided by the length of the blood stain. Now, I can't profess to tell you that I can do that math, but the result will tell you the exact angle that the spatter arrived from. Math is crazy that way. And if you have multiple stains, experts can string them together either literally or digitally to find convergence or the exact point of origin of the blood source. It's super cool. Now, there are factors that complicate the analysis. Surface texture, whether it's porous versus smooth, material absorption, like carpets versus concrete, or other environmental conditions like rain or wind, or an attempted cleansing can all complicate these calculations. So while it's definitely an emerging science, it's not absolute. In fact, a National Academy of Sciences report criticized BPA analysis for its subjectivity, calling for more standardization. It reported that error rates in lab tests can reach 15 to 20% in complex scenarios. That's why rigorous protocols from groups like the Scientific Working Group on Bloodstain Pattern Analysis are essential. Now let's move on to who can testify about these topics in court. And it's not just anybody. You obviously have to be an expert. Experts must be able to demonstrate reliability, testable methods, peer reviews, error rates, and acceptance in the field. For BPA experts, qualifications start with education, usually a degree in forensic science, physics, or biology. Then specialized training, at least a 40-hour basic BPA course, plus advanced ones, often offered from the IABPA, that's the International Association for Blood Stain Pattern Analysis. You can also get this kind of training through the FBI. And experience matters. The number of crime scenes investigated and/or lab experiments reconstructing scenarios with animal blood or synthetics is relevant. Certifications from respected international blood spatter identification organizations can also bolster credibility. And at trials, lawyers will ask, describe your training in fluid dynamics. How many peer review articles have you published? And these answers are important because a solid expert must be able to communicate complex science simply to juries. But faking it? That can be disastrous. One of the most famous cases comes from my home state of Missouri. The case involved the death of Lisa Jennings back in 2006. Her death was ruled a suicide. However, a police sergeant without proper BPA training reinterpreted blood patterns and claimed that no backspatter evidence at the crime scene meant it had to be a homicide. So, charges were filed, and then he testified as an expert at trial. The result was a conviction for her husband, Brad Jennings, who spent 8 years in prison before an independent review debunked the sergeant's testimony because, in fact, many suicides lack visible backspatter. Brad was exonerated in 2018. Then that case hit Dateline on NBC, and the sergeant faced lawsuits for his misrepresentation. Moral of the story, bad expertise in this area can wreck lives. On the flip side, when done right, BPA solves cases. A prime example is the 2007 murder of Gareth MacDonald in the UK. Gareth, aged 30, was found bludgeoned to death in a Travelodge hotel by a fire extinguisher. His boyfriend, Glenn Rycroft, claimed he had left, and when he returned, he found him dead. When authorities arrived, he was hugging the body, explaining the blood on him. But BPA expert Dr. Philip Avenel analyzed Rycroft's shoes and his trousers. They had impact spatter, tiny little contact droplets from being near wet blood during the blows, not just the transfer blood from holding the victim. The trousers also had clotted stains in addition to contact stains that indicated that time had elapsed between the initial blows and then when he was holding the victim. This evidence proved Rycroft was present during the assault and murder, not just afterwards. DNA and fingerprint analysis helped as well, but the BPA provided the sequence unavailable otherwise from DNA evidence alone. Rycroft would be convicted of the murder and sentenced to life in prison. This case shows BPA's power in reconstructing timelines and exposing lies. So at the end of the day, blood spatter analysis blends physics, biology, and detective work, but it demands true expertise. That's all I have for you today. I hope you enjoyed the episode. Remember, if you're in legal trouble, seek qualified pros. Thank you for watching. I'm Joshua Roberts, attorney at law, and you've been watching Lawyer Up.